It's Nobel Prize season, which means that we get to celebrate the progress that we've made as a species in understanding our universe, and we get to honor people who've played a big role in the most groundbreaking recent discoveries. This year, the Nobel Prize in Physics was awarded to 3 physicists, John Clark, Michael Devereux, and John Martinez, for demonstrating that quantum properties aren't always invisibly small. In their experiments, they observed quantum tunneling, a phenomenon where a quantum particle can effectively pass through a barrier without naively having the energy to do so, and they observed this in a macroscopic circuit made of many particles. So this discovery showed that many particles together can sometimes act as a single quantum particle, obeying the rules of quantum mechanics, and this paved the way for today's development of quantum computers. Now, I think it's awesome that the Nobel Prize brings the world's attention toward these sorts of achievements in research. But as with any prize where some people are being recognized, there are always lots of other people who also do great work who aren't. So today we are rerunning our episode on a few of the Nobel Prize's greatest misses. These are people who definitely deserved a prize who didn't get one for one reason or another. So stick around. You're listening to Why This Universe, a podcast where we break down the biggest ideas in physics. I'm Shalma Wegsman.
And I'm Dan Hooper. So every year around this time when the Nobels are announced, I find myself mulling over who has gotten these awards over the years and who I would have liked to have seen get one that didn't. I think mostly or overall in the big picture, they've done a pretty good job. Not perfect by any means, but pretty well. After all, most of the really big discoveries in the last 120 years of physics have earned a Nobel. And perhaps even more impressive is that none of the Nobels have gone to something that turned out later to be wrong. That's a lot harder to do than you might think. So I think all in all, thumbs up to the committee. But all that being said, there are definitely some instances where I think decisions could have been made differently, that important people were overlooked, sometimes for scientific reasons, sometimes for sociological reasons, sometimes for cultural reasons.
And if you think about the bigger picture, you might wonder what the point of awarding prizes in science to individuals is anyway. Science is naturally a collaborative process. And for any discovery, there are all the people who laid the foundations for it. The people who built the experiment, the people who debugged the code, and the people and discoveries that came before and made the idea possible. Usually, a lot of these people are neglected in these awards.
In this episode of Why This Universe, we can talk about a few of the people that I would argue should have gotten a Nobel Prize sometime over the past 120 years, but didn't. So let me acknowledge right off the bat that I have a lot of biases when it comes to the questions of which scientists are the greatest and most important and most worthy of a Nobel. After all, I'm a cosmologist and I'm a particle physicist, and that's what I spend my time thinking about. So when I come up with my list of people who should have won a Nobel Prize but didn't, they're mostly going to be cosmologists and particle physicists and things like that. In fact, today I'm going to limit my discussion to astrophysicists, cosmologists, people like that, knowing there are lots of other examples of scientists in other fields who, should make this list if I was trying to be more inclusive. Okay, so the first name of the people on my list of people that should have won a Nobel Prize but didn't is the astronomer Jocelyn Bell. So in particular, she was, pivotal in the discovery of pulsars back in the 1960s. So as a grad student, she helped build and then use a radio telescope called the Interplanetary Scintillation Array, which was just outside of Cambridge in England. This telescope detected really high frequency light or radio waves at a frequency of about 82 megahertz. And radio astronomy was really a new thing, and it was really exciting. This telescope was kind of at the cutting edge, and they were going to use it, they thought, to study objects called quasars, which had just at that time been recently discovered. if you're picturing, when I describe this telescope, if you're picturing something like a long tube with lenses or mirrors or something, you're not picturing the right thing. This is a big array of antennas over like a 4-acre piece of land. So radio astronomy is a really different kind of astronomy than you might have otherwise normally pictured. So on November 28th of 1967, Bell detected what she described as a, quote, bit of scruff in some data she had taken with this radio telescope in August of that year. The weird thing is that the signals seemed to pulsate with a remarkable degree of regularity. It was like a new pulse every 1.3 seconds, and it just continued indefinitely. The longer she measured it, the more that pulsation seemed to appear. They originally nicknamed the signal LGM1 for Little Green Man 1, but that was just a joke, of course. And it turned out to be the first discovery of an object that we now call a pulsar. From the fact that the signal was pulsating every second or so, or 1.3 seconds, you can work out that whatever makes a signal like this has to be pretty small. After all, even traveling at the speed of light in 1.3 seconds, you can only get a few 100,000 kilometers. So this is something the size of a small star or smaller, which is pretty interesting. And as it turns out, we now know that it's even smaller than that. This isn't just some, red dwarf or something. This is something we call a neutron star spinning at one time a second around its axis. Now, a neutron star is not made of protons and neutrons and electrons like ordinary matter, but is basically a big chunk of all neutron matter. And a chunk of all neutron matter that weighs as much as the sun, you can fit into something the size of a city, maybe 10 kilometers in radius or something. So really exotic material, something had never been observed before. It was a really important discovery, not only in radio astronomy, but just in astrophysics and physics at large. So based on the signal that Bell had found in their data, she co-authored a paper with 4 other astronomers announcing this discovery of these pulsating radio sources that would become known as pulsars. In most subfields of astronomy, the first name on the author list is kind of the privileged status. You know who the main author is by whose name is first on that author's list. This isn't true in my field of particle cosmology, but in a lot of fields of astronomy, it's true. And in this case, Bell didn't get that privileged position. Instead, the first author position went to her PhD advisor, Anthony Hewish. Now, Hewish was an important radio astronomer, no doubt about that. But I think it's fair to say that Bell really deserved that, prestigious first authorship on the discovery that she played such a pivotal role in. But all the same, he wound up in that spot. And then years later, when everybody had agreed that they discovered pulsars and the signal was real and all this stuff, the 1974 Nobel Prize in Physics went to Anthony Hewish and another radio astronomer named Martin Ryle for their pioneering work in radio astrophysics. Bell had been left out of this story, or at least left off of the Nobel Prize, and given to her PhD advisor instead. So Bell's omission from that year's Nobel Prize was controversial from the very beginning. The famous astronomer Fred Hoyle, who you might have heard about in the context of steady-state cosmological theories, argued from the very beginning that it should have gone to Bell. And he wasn't alone. This decision just seemed remarkably biased, even to the kind of conservative astronomy community at the time. And they looked at this as an example where an older and more senior person who had not done the main work or had the main discovery got most of the credit, and the younger, and in this case, the younger woman who was involved, was left out of the story.
Coming up on Season 1 of Crew Collective, how storytellers are telling stories about space. Now streaming wherever you get your podcasts or at crewcollectivepodcast.com.
It's a wonderful thing, and if you get a brilliant idea and you can make it into something that contained, that's great, and then it's one and done and you move on to the next one and you can do something completely different. You get the option to absolutely flip it on its head the following episode. You could do something in a completely different style or a different method of storytelling.
How did people know that Bell did all the work if her name was second? Did it just come out after the fact? Or,
Yeah.
like how else would you know if you didn't know personally, what happened in the room and you just saw the paper?
Yeah, I think if you just had the paper, you wouldn't have any way to know. But we have human beings to talk to. We have interviews to conduct. We have, people's various recollections, and we can kind of piece together the history in a lot of cases, maybe imperfectly.
Huh. Yeah, this makes me think like maybe there should be a more standardized way to do authorship that is not based on seniority, but based on how much work you put into the paper.
The main thing, if I were to, going to invent the system of authorship or other ways of divvying out credit, the main thing I would keep in mind is what's a system that would encourage the most productive science to be done. So in particular, in my field, most papers are authored alphabetically. So, it's an arbitrary way of doing it, but it doesn't give priority to anybody. Everybody's name is equally weighted on that author list. So that encourages people to collaborate because, they don't have to worry about who's going to get that first author spot. You can do a little work, you can do a lot of work. And the person with the idea and the person who does all the hard data analysis all get included. And if it's a really big discovery, the historians will come around and ask who did what. But, I personally prefer that. I prefer that to a first author model. So I'm not one to argue that every scientist who's involved in a major discovery needs to win a Nobel Prize. Sometimes someone just happens to be in the right place at the right time, and it's just kind of dumb luck that they stumbled onto that particular discovery. And I don't think you need a Nobel for every time that happens. But when it comes to Bell, I don't buy that applies. I think she really does deserve it. After all, she was one of the main players in building the telescope she used. So even if you want to argue that she just happened to have the right telescope at the right time, she built that telescope. So she gets the credit for that too. Two, she had to analyze a ton of data before she found the signal in question, night after night after night of, painstaking work. So, the way I like to think about it is, sure, she found a needle in a haystack, and sometimes people find needles in haystacks from luck, but she had to spend a lot of time looking through hay and haystacks before she found that pulsar. So I think that's not a good reason for her to be excluded. And then thirdly, apparently her advisor, Anthony Hewish, didn't take the pulsating signal very seriously when Bell brought it to him. It took a long time for Bell to get him to really listen and take this seriously and eventually publish the results. If it weren't for Bell's persistence, it's possible that group wouldn't have published this at all, and it would have been who knows how much longer before pulsars were discovered. So, in light of all these reasons, let's ask the question of what the committee was thinking. Why did the Nobel Committee screw this up so bad? And, of course, I wasn't there in the room. It's all very secretive and everything, but I can think of two pretty obvious factors at work. First of all, she was a student. She was a grad student at the time. And there are lots of instances where students are overlooked by the Nobel Committee. There are exceptions, like Marie Curie and Louis de Broglie both got Nobel Prizes for work they did when they were students. More recently, Frank Wilczek, David Gross, and Hugh Pollitzer all got their Nobel for work they did on QCD, quantum chromodynamics, when they were grad students. And there are probably lots of other examples. Those are just the ones I know off the top of my head. And there are lots of professors out there who promote the work of their grad students fairly and equitably. And, I think that's more common than not. But there are also some who don't. Some who might look at a big discovery and say, I would rather have my name be on that than my students. And maybe they have the power to make that happen. So that happens sometimes. I like to think we're getting better as a community. Maybe that's just Pollyanna-ish. But, I like to think that things are a little better than they were in 1967. But still a long way from perfect. I think there's another really big elephant in the room that drove this decision, or likely drove this decision. I can't be sure, but I think it's sexism. At that time, for sure, and to some extent in the present time, but especially in that time, women, and especially younger women, were just not taken seriously as scientists. They would look at her and they would look at her older male advisor and find it very easy to believe that older male advisor was the real scientist involved, and she was just kind of around. This stuff still goes on today, but it tends to at least be more subtle. But back in the 60s and 70s, it would just be overt. No one even tried to conceal it. Bell would later describe the way that the members of the media would talk to her and Hewish about their discovery. So they would conduct interviews and they would ask him all the questions about the science. And then they would ask her like softball personal interest questions, like how many boyfriends she had or about her hairstyle. And where it gets really gross is they ask questions, or not ask questions, but they ask her to like unbutton her top button to make for a better photograph. And like, it was really, pretty gross stuff when you listen to her recollections of this. So the good news in all this is that despite all these challenges, like pretty much everybody knows that Jocelyn Bell is the one who discovered pulsars today. If you just go and ask an astronomer who discovered pulsars, they would tell you her name long before you would hear Anthony Hewish mentioned. And also she's had a great career. She had research positions at various times at University of Southampton, University College London, the Royal Observatory in Edinburgh, among others. More recently, she was a visiting professor at Princeton. And between 2008 and 2010, she was the president of the Institute of Physics. And in 2018, she won something called the Breakthrough Prize, which is a more recent award than the Nobel, but it actually comes with more money. So in a sense, she came out ahead in this game. All right, so putting Jocelyn Bell behind us, the next group of people I want to mention as potential Nobel winners that were overlooked are just kind of the mid-century population of cosmologists. So if you look over the history of physics, or the history of science for that matter, the fact that cosmology grew out of really nothing in the early 20th century to this incredibly detailed and influential branch of science where we know the universe started as a Big Bang and evolved in detail in all these ways, like all of that's pretty amazing. And until just a couple of years ago, no cosmologists got a Nobel Prize for any of that work. Now, there's an asterisk, and I imagine some of our listeners are going, what about Penzias and Wilson, who discovered the cosmic microwave background? They got a Nobel Prize, but they weren't cosmologists. They were radio astronomers who kind of, accidentally discovered this cosmological signal, which was really important, and they were really good at their jobs, so they deserve credit, but they weren't cosmologists. So I'm putting them out of that category for these purposes. So when I think of a cosmologist, what I mean by a cosmologist, I mean somebody who's actively thinking about and working on questions of how the whole universe or the large scale universe has evolved and changed over time, whether that be what the young universe was like and the Big Bang was like, or whether it's about how the large scale structure of our universe evolved and changed, or studying how the universe has expanded or cooled over time. Those things are all cosmology. Anyone who that's the primary thrust of their research, I would be happy to call a cosmologist.
In contrast to, astronomers or astrophysicists who study, stars, galaxies, these systems within the entire universe.
Yeah, and Penzias and Wilson, used their radio telescope with the intent of studying radio emission from the Milky Way. They weren't intending to do cosmology, but they just found that they had this background signal that they couldn't get rid of. Turns out to be really important for cosmology, but that's not what they were looking for, and that's not what they thought about on a day-to-day basis. So in 2019, the Physics Nobel went to Jim Peebles for, quote, theoretical discoveries in physical cosmology. And this award was super well-deserved. Like, I wrote a op-ed at the time praising the Nobel Committee for that decision. I thought it was, well past due that a cosmologist would win the prize. But in some ways, it's like too little too late. If you look back farther, there's just this long list of cosmological heroes, at least to people like me, who were never even given consideration by the Nobel Committee, as far as I'm aware. Here I have names like George Gamow in mind, or Ralph Alpher, Robert Herman, Alexander Friedman, George Lemaitre, Robert Dickey, Yakov Zeldovich, and many others. But those are like at the top of my list. So we all look back on history of cosmology and appreciate that it was incredibly important to our intellectual history now, but that makes it hard to understand why the Nobel Committee overlooked them for so long. My read of the history, which might be imperfect, but it's my best kind of speculative or informed guess as to what went on, is just the way that cosmology was viewed around that time. For a long time, cosmology wasn't really seen as a respectable branch of science. It was seen as speculative and maybe, approximate and crude, and that maybe their results weren't trustworthy. That was kind of a widespread opinion throughout much of the 20th century.
Where did it come from?
Well, it was hard to measure the things that provided a foundation for cosmology. I mean, think of Edwin Hubble's original measurement of the expansion rate of the universe. In hindsight, we know he was right. The universe is expanding. That measurement was correct in that sense, but he was off by a factor of 7. Like, he thought the universe was expanding 7 times faster than it is. And that's because, getting all the systematic errors involved in these sorts of measurements under control is really, really hard. So as an outsider, you might look and go, oh, those cosmologists, I don't know that you can trust anything they're doing. And, the work that was being done in the 40s and 50s, was plagued by a bunch of people arguing back and forth, maybe past each other. It wasn't obvious people were converging to a consensus view of our universe's history. But by the 1960s and 70s, that had started to change and things were coming together. The Big Bang was becoming pretty rigorously established, and more and more the details are being filled in. But of course, people have it in their minds that this cosmology thing is really approximate and speculative and crude, and it takes a while for that to change, So it did change, but it took decades for that to happen. And by the time that happened, most of the heroes on my list, had passed on. So it was probably hard to give those prizes to the people who most deserve them. If I were to get in the head of the Nobel Committee and try to figure out what was going on behind those decisions.
Does the Nobel Committee never award the Nobel to someone who's passed away? Is that a rule?
My understanding is that's a hard rule, that you have to be alive to receive a Nobel Prize. Yeah.
Okay. Yeah. Interesting.
So if I could only pick a couple of figures from my list to retroactively give Nobel Prizes to, I think I would pick George Gamow and Ralph Alpher. So in the 1940s, these two played a really important role in understanding how nuclei were forged in the hot Big Bang. So this is in the first seconds and minutes after the Big Bang. Basically all the helium and deuterium and stuff that's in our universe today was formed then. And that provided one of the first and really critical and important tests that our universe did in fact emerge from a Big Bang. They also made critical predictions that the hot Big Bang should have left behind a big background of radiation, what we now call the cosmic microwave background. And when that was discovered by Penzias and Wilson in 1965, it provided probably the single biggest and most important piece of evidence that our universe did start in a Big Bang. But if it weren't for people like Gamow and Alpher, we wouldn't have known that that was a prediction of the Big Bang. We wouldn't have been able to put all that information together in a coherent way. So George Gamow died in 1968, only a few years after the cosmic microwave background was discovered. So it probably just wasn't plausible he was going to get a Nobel Prize in that narrow window of time. Alpher lived a lot longer. He lived until 2007. And I can't put my finger on why he was never awarded the Nobel. I think he should have gotten one. If I had been on the committee, I would have made that argument. All right, so my third choice for a scientist who was overlooked by the Nobel Committee is Vera Rubin. Although many people were involved in the discovery of dark matter, I think Rubin was probably the single most important figure in that discovery. She did incredibly important work, seminal work back in the 1960s and 70s, in particular in observing how stars and gas rotate around galaxies. So when you look at something like the solar system and you measure different planets and their speeds around the sun, you can deduce the mass of the sun. If you look at a galaxy and look at how the stars and gas and stuff like this are rotating around a galaxy, you can deduce how heavy or how much mass that galaxy has and how that mass is distributed throughout the galaxy. So just like a solar system, you expected, at least the astronomers at the time expected, the stars and gas on the outskirts of galaxies to be moving a lot more slowly than stars and gas closer to the galactic center. And this is the same reason why Pluto moves much more slowly than Mercury. But that's not what Rubin observed. Rubin found that it was about the same velocity no matter where you looked, on the outskirts, near the inner parts of the galaxy. All this stuff was zipping around at about the same velocity. And what that implies is that most of the mass in these things isn't made up of stars, gas, dust, or planets, but of something else that doesn't appreciably radiate, reflect, or absorb light, and that is spread out over a much bigger volume of space than the stars, gas, and dust are. We still don't know what this stuff is, but we call it dark matter, and Rubin's work was absolutely central to us figuring out that this stuff exists in our universe. So about every year or so, I think, I get a letter from the Nobel Committee, and lots of my colleagues do too, asking me to nominate somebody for the prize. And I assume a bunch of scientists send in these letters or these forms with their own opinions, and the Nobel Committee kind of, considers the various options and things. I don't think they're bound to take somebody we nominate, but maybe we'll play some role in this.
Yeah, that's it. I didn't know that they just asked, professors around.
I didn't know until I got my first letter like this. Maybe somebody's just spoofing me. I don't know, but I send one in every year. But in my case, about 10 years ago, I started writing Vera Rubin every year until she died in 2016. And I've argued for a long time that she makes logical sense for this particular award. Then when she died in 2016, we knew that will never happen. Shortly after that, the famous theoretical physicist Lisa Randall wrote an op-ed in the New York Times arguing that Rubin should have won a Nobel. I certainly share her views on this. And frankly, when I ask my colleagues, most of us tend to agree that Rubin merited a Nobel. It's always surprised a lot of us anyway, that she didn't get one.
Yeah, especially in the field that we both work in now, it's like the central issue that everyone's trying to solve is, what is the dark matter? It's like employed so many people past her discovery. There
are literally thousands of scientists who the thrust of their research is dark matter. And, the single most important person in that story probably deserves a Nobel Prize, you would think. So with that in mind, let's try to figure out maybe why she was overlooked. Again, I wasn't in the room, but I can think of at least a few reasons, factors that might have contributed. First of all, it's fair to say that the discovery of dark matter was complicated. It didn't go from point A to point B quickly in a straight line. It kind of meandered around over many decades. Let's compare it to Jocelyn Bell's discovery of pulsars. So she made this measurement, she made this observation. They wrote a critical paper announcing the discovery, and within a few years, everyone agreed pulsars were real and that they were in fact rapidly spinning neutron stars. Case closed. Dark matter, there was some evidence for it all the way back in the 1930s. It wasn't very convincing evidence, but there were papers written talking about dynamics of galaxy clusters in the 1930s that we now think of as evidence for dark matter. All the work by Rubin in the 60s and 70s was really important, but other groups were also contributing to the story around the same time. And then later measurements of the cosmic microwave background and large-scale structure and the light element abundances from the Big Bang and galaxy clusters, all this stuff all contributed to the story. So unlike the pulsar story, you can't say this is the one singular thing that did it. It's a bunch of people who played a bunch of different roles. This actually goes back to the opening that you expressed, Shalma, that science isn't very often all about a single, person's discovery, but about giant collaborative efforts. And that is how dark matter played out. That being said, I think if you had to pick one person as having more influence over this story than anyone else, I'd still pick Rubin. The second reason that I think may have been a factor going into why Rubin never won a Nobel Prize comes down to the fact that we still don't know what dark matter really is. We know it's there. We've measured its distribution. We've measured certain things about it, but we don't know what kind of substance or substances make up the dark matter. And some of my colleagues I've heard express the view that until we know what dark matter is, no one should get a Nobel Prize for it. To put it bluntly, I think this opinion is pretty stupid. I don't go around saying that all that often, but in this case, I think it's an accurate description of my opinion. There are a lot of Nobel Prizes that were given for things that were important discoveries that we didn't really know what was all behind them yet at the time. So a really good example is dark energy. So three cosmologists were awarded the Nobel some years ago for the discovery that the universe's expansion rate is accelerating, which implies the existence of dark energy. But we don't know what dark energy is. We don't know why it's there, especially we don't know why it's there in the abundance that it is. So there's still tons of mysteries associated with dark energy. But I think that makes sense that got the Nobel. It is an important discovery, incredibly important. Just because you just, give a prize to something doesn't mean you're done working on it. And we can still work on dark matter and figuring out what it is while honoring the contributions to people like Vera Rubin, who taught us it was there in the first place.
Right. And I don't know. In my head, it makes sense that you could do two prizes. One about, discovering that it exists. We actually know a lot now about, where it is and how much there is, despite not knowing what it's made out of. We know all these things because of these discoveries. And then, in the future, when we finally figure out what it is, that could be another Nobel Prize.
And I'm sure that when we discover what dark matter is, there will be another round of Nobels. And that makes sense. These don't have to be mutually exclusive, just like you were saying. And then the third factor I'll mention that, again, is the elephant in the room is the factor of sexism. Rubin's seminal work took place at a time when there were very few women in working as astronomers or even as other kinds of scientists. And this put her repeatedly at a disadvantage. People would look at her work and they would look at her and they would find it easy to overlook her and not take her seriously as the incredible scientist and astronomer she was. I don't buy for a second that she would have been treated that same way if she had been a man. I'm confident that she would have won a Nobel by now if it weren't for that particular factor.
And the other elephant in the room is how underserved people of color have been by the institution of science. We've talked about sexism in this episode, but still, everyone on our list today has been white.
That's true. And I mean, to some extent, that reflects what the scientific community during these periods of time of these discoveries looked like. And that's a part of the reason why there's so many more men than women on the list too. In many ways, the Nobel Prize is a lagging indicator of this sort of progress too. After all, I mean, a Nobel Prize is given usually for discoveries that were made a long time ago, decades ago. And so maybe we've made a certain degree of progress on some of these fronts, but we're giving prizes for things were done before that progress was made.
And there's a lot of progress that still needs to be made. Like I mentioned in the beginning of the episode, any biases held by the Nobel Committee are going to be reflected in their choices for who wins the prize. And there's no telling that the amazing work being done by people of color in the field today are going to be recognized to the same degree as these other white men. This has real effects beyond just who wins the Nobel Prize. After all, the winners of this prize serve as symbols of heroes and role models in science.
And it's clear that like all those role models I just mentioned that I had when I was young, they're all white men, right? And so that is problematic. That for me, who's a white man, I got to look at these heroes who look and, seem like me, like older versions of me, and I could be inspired. That might be harder for some other people.
Without a role model that you can identify with, it's hard to feel like you'll be wanted and accepted in the field of science. So hopefully in the future, our institutions of science can become more equal, more diverse, and be reflected in a more diverse set of Nobel Prize winners. Why This Universe is produced and edited by me, Shalma Wegsman, and our co-host is Dan Hooper. Dan is a professor of physics at the University of Wisconsin-Madison and the director of the Wisconsin Ice Cube Particle Astrophysics Center. If you like our show and you want to support us, you can join us for as little as $3 a month on Patreon. There you can also get access to exclusive Ask Us Anything segments where you can directly ask Dan and I any of your questions on physics or whatever else. And to find that, just go to patreon.com/whythisuniverse. As always, thanks for listening.